Hi everyone, I think we are live now. So welcome to another Memgraph community call. Today I have guys from FI Consulting with me. That is, we have Robert, who is actually Director of Data Science. We have Sinan, who is a Senior Data Scientist, and we have James, who is a Senior Solutions Architect with us. And today they are going to tell us a story about how they are working on a RAG system with Memgraph and DeepSeek. I'm looking forward to hearing how they kind of build this puzzle with RAG because it's definitely not one option. It's not the one way to go. And I want to hear how they build their own. And I guess a lot of guests are interested as well. I see people are starting to join. But yeah, before we start, just a small information on the Crowdcast side. So we have a chat. If you want to chat or ask anything, do it there. But if you have a question that is quite specific to what they are talking about and you want us to get it answered in the Q&A after the presentation, please post it in the questions tab. So it's the little one with the question tab. I can, just because it's easier for us to answer it and manage it through there. And we will also have a couple of polls posted in the poll sections. Make sure to check that out as well. And yeah, I think that's it. People are continuing to join us, so I think we can slowly start. So I would say, Robert, Sinan, and James, thank you for joining. Thank you for agreeing to do this. And I guess the stage is yours.
All right. So welcome everyone. We're FI Consulting. We're based in Washington, D.C., and we've been working with graphs and Gen AI applications now for a bit. And we're excited to share what we learned with you guys. So we have a slide deck that we're going to go through, and then we'll go through some live demonstrations. And as Katerina said, if you have any question at any time, feel free to ask it. We can turn it into an interactive discussion. So yeah, looking forward to it. So. Okay. Yep. Excellent. Yeah. There we go. All right. So when we talk about retrieval augmented generation, here's kind of an architecture diagram giving a broad overview of what such a system might look like. So the idea is that on the left, you have a user interface where the user wants to obtain some kind of information or ask a question. So maybe they ask a question, and this is kind of relevant to our organization. Maybe they want to ask a question about the Department of Agriculture, and they say, okay, send me information on proposals that we've done for the Department of Agriculture in the past year. All right, so the question comes in from the left. Are documents that could answer, no. Yeah, we had a lag, okay. Our documents that could answer the question come in from the right, and they're coming in from your content management system, let's say SharePoint, for example. And then the idea is that all your documents get fed into a graph database, such as Memgraph. And the idea from there is that we can run algorithms that will then choose the relevant portions of the document that answer the question. Okay, now what do I mean by relevant documents? Well, let's kind of put that aside for now, but let's kind of assume that our algorithm is able to pinpoint exactly where the answer to your question can be found. We send those relevant documents to a language model down here. DeepSeek is a very powerful language model, fairly recent, and we're going to explore that. And then the idea is that DeepSeek is going to take your documents and answer the question based on your context, which is extremely important for many use cases, because we want to answer questions based on our internal knowledge. We can ask, the wider, World Wide Web, but oftentimes we want to make sure that the answer is grounded on our kind of private proprietary information. Okay, and then we generate the answer, it goes back to the user interface, and then your answer appears in a natural language format. All right. Yep. Okay. Okay. So why is this a hard problem? And it is a hard problem. I think many of you on the call have probably done some experimentation with large language models and going on ChatGPT and things like that. But the hard part is that it's very difficult to get these answers to return accurate information, that we can trust, that doesn't have any hallucinations or any kind of anomalies. And then it's also very difficult to get it to answer based on your context. Again, often organizations, we don't want to, use too much information kind of from the outside world. We want to find the answer in our documents. So we have an example here. On the left, we do this retrieval augmented generation without the graph database. Okay, and you can see what the response might look like. And then on the right, we kind of have our framework of the vector search plus the graph. Okay, and you see the answer is a bit more content. We've checked it for accuracy. It's a much more complete answer. And we find that this graph database really helps us to get the answer in the way that we want it. And you might find that this difference in quality is often very important to get your organization to embrace Gen AI and to kind of buy into it. Because unfortunately, people don't really fully trust, Gen AI systems yet because they're worried about the hallucinations. They're worried about, not getting an incomplete answer. And it's very important, especially when you have some kind of customer facing business, that your answer is accurate, complete, and the way you want it without any hallucinations. Okay, so here's kind of another architectural diagram. And the idea is that we see this kind of graph plus the language model as kind of a best of both worlds approach, okay? Because the graph database provides structure and it gives the answers more kind of grounding context. And then the language model can provide that kind of natural language response, okay? So they kind of work together really well. Another reason why we use the graph database is that we often have our own language and our own terminology that only is specific to our domain. For example, we have a lot of acronyms, like CSC, the credit subsidy calculator. We have a lot of our own abbreviations like RD. When we say RD here at FI Consulting, we usually are referring to the Office of Rural Development, not research and development, right? And a lot of times, OpenAI or DeepSeek, because they're trained on kind of the general corpus of knowledge, they're not going to know like your specific lingo, your specific terminology that you use. But we can actually put that in the graph database. And again, we'll get more accurate, more complete responses. Okay, so now we'll kind of get into a little bit more of the details about our solution. We'll talk about how we prep the data, which is really half the battle in getting these RAG systems, up and running. We'll talk about how we use algorithms to retrieve the most relevant documents that we then pass to the language model. So very important step of how you kind of filter out all the irrelevant information and make sure that you're obtaining the exact documents that answer your question. And then we'll talk about the language model side of things. We'll talk about the prompt engineering, the way we fine tune the language model and things like that to kind of format the natural language response. Okay, so starting with the data preparation, a lot of our documents here at FI are over 100 pages, long, okay? And it's very difficult to take 100 pages of a document and put it into one vector for language processing. So you have to do some kind of chunking strategy, okay, where you have to break up big documents, and then that will enable the vector embedding to be more accurate, right? So this is what we do at FI, okay? And every organization is going to have their own chunking strategy. And this is kind of like a hyperparameter that you can calibrate because you'll find that different chunking strategies might work better with different types of data. So what we do here at FI Consulting is that when we get a really large document, we split it up into 4 to 5 page smaller sections, okay? And then we take those 4 to 5 pages, and then we split them up into 2,000 tokens each, roughly 1.5 to 2 pages, and we call those parents. And then we split up the parents into 200 tokens each, which is roughly 1 to 2 paragraphs of text, and then we call those children. All right, so we kind of developed a hierarchy where we have the 4 to 5 page documents kind of at the top level, and then we have the parents underneath, and then we have the children underneath. And I think you can already see how this might fit nicely into a graph database structure. All right, so then what you need to do is you need to put the children, chunks of text into your language model so you can get a vector representation of that text. Okay, and this is kind of another choice, that you want to make. And, this presentation is about DeepSeek, but you can use any large language model you want. And they really differ in terms of quality and all that. So you have to experiment around and find the best language model that works the best for your task. And we put them into a vector. Here's another hyperparameter. How long do you want your vector to be? Okay, so you have to do some trial and error there. I think we're using length 1536 for our vectors, all right? And then we can load that vector directly into the graph database, okay? So you can see here on the left, we have our child text of 200 tokens. And then on the right, we have the vector embedding representation, 1500 length vector. And then you can see how it goes directly into the graph database. All right, so this is kind of like a high-level representation now of what the graph database might look like. And again, we kind of have that hierarchy that I talked about where the documents are in purple. Those parent, 1.5 to 2 page sections of text are in orange. The children nodes, 200 tokens each, are in blue. We also have what's called NER, which we're going to talk about in a second. And that's another way to kind of filter the graph and to kind of help improve the speed of the retrieval. And then we have the vector embeddings in another node that is connected directly to the child nodes, and they're in brown. Okay. All right. So what did I mean when I talked about NER? NER is named entity recognition, and the idea is that we want to capture, all the entities or all the, objects, in our data, the people, the places, the things, the organizations. It can really be anything you want that can help you, parse the information better. And here's our opportunity to put in our own language, our own lingo, the acronyms that FI Consulting uses on a regular basis. So we have a lot of special terminology, like IVNV, DEFCAP, SBLF, things that a general language model might not recognize. And here's our opportunity to kind of put that in the graph database to kind of help the language model understand what it is we're talking about, okay? And then we have a file, and it's called the NER file. And this NER file kind of catches like synonyms. So like, let's say you have the Department of Treasury at the top, and somebody out there is saying, oh, okay, I'm not going to call it the Department of Treasury. I'm going to call it treasury.gov, or I'm going to call it the US Department of Treasury, right? So we have this kind of like alias file, okay, to make sure that we capture all the different ways that somebody might refer to the same organization, okay? Same thing with Fannie Mae. Some people might use a full name like Federal National Mortgage Association. And, language models are getting better and better all the time. And they might pick up on this stuff. Like, OpenAI might know that Fannie Mae and Federal National Mortgage Association, refer to the same thing. But we don't really want to take that for granted. And that's why we have the NER file to make it as easy as possible for the language model to understand, our own lingo, our own terminology. All right. Okay. So now somebody asked a question, and they asked the question, what is the role description for a project manager at DOE? Okay. So we go back to our NER file, and we know that DOE is an acronym, and it stands for the Department of Energy. So we do a quick find and replace, okay, and we replace it with Department of Energy. And then now we go to our graph database, and we find the node, that NER node that we put in earlier that contains the words Department of Energy. And then we have all the documents that mention the Department of Energy, connected to that node in the graph database. And so now we've kind of sped up the retrieval of the documents we want to look for. Instead of doing a comprehensive kind of vector search across the entire graph database, we've now filtered a subsection of the graph database to now only look at the most relevant nodes that talk about the Department of Energy. And when you talk about information retrieval, it's very important that it be fast. And when you talk about all the documents you might have to search through, like these, techniques, really speed up the efficiency and, the speed that you get your answer back, which is very important when developing a chat-based application. All right. So now, do you remember when I was saying that we have algorithms that we run to pull out the relevant documents? Okay, this is how we do it, and it's only one way. And I'd be curious to hear other ideas out there. But we have an algorithm that we like, and it's the Facebook similarity search algorithm, and it's basically doing cosine similarity, but it's optimized, using hashing and all kinds of techniques to kind of speed up the cosine similarity search. And FAISS will return you like maybe the top 10, top 20 vectors that match your question. And so here we're returning, I guess, 9, vectors. And then we have the IDs, that relate to the vectors, and then the actual text. And then the idea is that we can search the graph database, to find the best, match that corresponds to our question. Okay, here's another important step. The FAISS algorithm is great, but you have to kind of fine tune it. Okay, so we use a re-ranker, all right, and there are lots of re-ranker algorithms out there. And the idea is that the FAISS is kind of returning you the top 10 or the top 20 or top 30, and then you run those, that top 20 through the re-ranker, and the re-ranker is kind of doing a more intensive, kind of search, and then it will re-rank, the importance of the top 20 returned by FAISS. Okay, so now we can see that the order of the vectors has kind of changed after we ran the re-ranker. Okay, so the one in the top position is still number 1. You can see here, but then the one that was previously number 7 is now number 2, and then the one that was previously number 2 is now number 3. So on and so forth. Okay. We have found that re-ranking is a very important step to make sure that we're sending the language model, again, the most relevant pieces of information, and it really does improve the accuracy of your responses. All right. Okay, so now we've prepared the data, we've retrieved the relevant documents. Now it's kind of like the fun part where we kind of feed that back into a language model. We can do prompt engineering, and prompt engineering will help us kind of format the response, right? Like, do we want it to be in like an email, or do we want it to be like in a report? Do we want like a bulleted list? You have a lot of different options now of kind of instructing the language model, like how you want the answer to look like. Okay. And then, if you're familiar with prompt engineering, you can assign like a role, like, I'm like a, director, or I'm an AI assistant. And that kind of helps kind of format, like it kind of tells a language model, like, how should I format this answer? Like, what kind of tone, what kind of style do they want the answer to be in? You can also say, don't use any creativity. Okay. And that kind of relates to the temperature of the prompt. So if the temperature is 0, that means like we don't want the language model to kind of, add its own creativity to the answer. Like we just want like the bare bones, just give me the answer. Okay. If you set the temperature higher, then the response is going to use more creativity. They might weave in more kind of outside knowledge, and it might come back like kind of stylistically, more interesting. But depending on what it is you want to do, a lot of times we just want the answer. And if the LLM can't find the answer in our data, we want it to say we can't find the answer. We don't want the LLM to hallucinate and just kind of make up something, right? We want to say, okay, temperature is 0, therefore just give me the answer. And if the LLM doesn't know the answer, just say you don't know the answer. All right. So, we test this on a lot of different, in a lot of different scenarios. Like we talk to our business people and we say, okay, like here are the questions that we gave the LLM. Is that answer yes, correct, yes or no? Could the answer be improved? And so, you have to undergo like a lot of testing and making sure that when you continue to like fine tune your model, that you've actually tested out the quality of your answers, with the population that's going to be using the tool. All right. So that being said, anyone have any questions right now before we kind of jump into the live demonstration?
One question.
Yeah, we have one question.
Mm-hmm.
So, can named entity recognition be used with different languages at the same time?
Yeah, that's a really interesting question. Okay, so we're based in DC and we do a lot of work with the U.S. government. So most of our documents are in the English language. That's something I'm not really qualified to answer because we don't really work in foreign languages that much. But
any LLM, if they support the different the languages other than the English, because some even the open source LLMs, they only working with the English version, smaller than the multi-language version. So for the NER, yeah, definitely. If you're using the OpenAI, I think is supporting the so many different languages. When we extract the NER with the OpenAI, yeah, it can give the results. But if you're using some models, just regular training for the English, the books or the documents, it will not support the NER.
Yeah, thank you. We have another question. So let's put it on the screen. Can you have an already structured graph? So totally different graph, like a user has post, which is post, and put a chunk in post, for example. So maybe a different approach.
Yeah, absolutely. And really, that's the whole reason why a lot of people do not use graph databases, when they create these, RAG applications. But we feel that it really is essential because it's all about getting the highest quality answer you can. And if you can use the graph, edges and relationships to kind of direct, where you want the answer to go, it's really going to improve the response. Language models really have trouble with hallucination, right? They're accessing a very wide range of data, and sometimes it's very difficult for the language. It's too much, honestly, to ask the language model to really come up with a perfect answer every time, considering all the data that it's looking at. And any way you can kind of filter down the context of where you want the answer to come from through graph relationships, it's only going to improve the quality of your answer. One of the things that we found is that if you give like a language model like Gemini or whatever, if you try to ask it to do like a mathematical calculation, like saying something like, show me projects between 2020 and 2022, you'd be amazed how difficult it is for a language model to understand like what you mean, and for it to only give you documents between those two dates. And that's the reason why we feel like, again, that graph plus language model is like the best of both worlds, because then you can kind of filter down the context to exactly what what area, what dates, whatnot you're looking for, and then only send that relevant context, to your language model.
Yeah. Thank you, Robert. Those are the questions we have so far. So maybe you can head over to another part of the presentation.
Yep. Mm-hmm.
Yeah. As Rob mentioned previously, this is our original the Memgraph. As you can see, our Memgraph. This is the the child documents. When we go to here, we can see all the taxes with the 200 tokens.
I don't see it. You see it? Oh no, it's coming. Okay.
The taxes, the child notes, and then the child notes also has its own. I think it's going all the way to here. It has the own embedding, the size of the 1536. For that one, we use the OpenAI, the text embedding small one. It's on the 1536, but there's so many different. For example, if you use not the small one, the larger model, you can get the 3000. Or nowadays, DeepSeek is coming with the 5102, the size of the embedding. The only, as you know, that when the embedding sizes get the bigger, and when you have so many embeddings, for example, millions or millions, when you do the similarity calculation, sometimes take a little bit, the time than the other one. And then this is our parent documents. As you can see, the parent has the longer text version than our child one. And then all the parent is going to the documents. When I extract this one, this document is also another parent, because each of them is the 5 pages, and these are around the 2 pages or 3 pages. This is the other child documents here. When we extract our documents, I cannot see give me 1 second. Here we go. Yeah, this is our NER. It's mentioned about how many parents have mention about this the NER. So generally, when we using the NER, it's our the first the first filtration, because thinking about the documents is you ask one question, and then you would like to to get the information about the specific, like a Department of Treasury, and then we are also putting some weight in here. For example, one document, yeah, it's mentioned about the Department of Treasury, but all this the documents, it's only mentioned at one time, and then there is another document, it's talking about the Department of Treasury 10 times. So when you ask the the question about the Department of Treasury, so you would like to go to the documents that are mentioned this NER more than the one time. Maybe the other one is only just a mention, just a refer, but there is no any information about the Department of Treasury. We have also I can show you here. When we asking the question, we also the asking giving some information about the weight, not only for the our the NER finding, but also there is some limitation with the weight. For example, in this one we said that 2, but it can be the increasing to 4, 5, 6. According to how you want to to get the result, because the LLMs, it's very good, but the only the backup I can say is for the hallucination, because sending to the context, the finding the context in the 1,000 documents or 50 documents. I prefer personally the top 50 documents instead of sending the the 1,000 documents, because of the the searching and everything. Maybe it's get some unrelated documents, and because of this one, the result maybe are not that I expected. So for that reason, we are also putting the weight. The other one is nowadays we also work on, this is another version. Okay, I asked the question, but for example, the NER not showing any documents. So what we to do at that time, because automatically says, okay, this NER is not there. So he said, I don't know your question answer. But maybe the related one, we would like the finding, they're making a shortest path, getting the the documents, they have the most common NER they are mentioning. Maybe the not directly this NER is mentioned, but on the question, maybe for example, if I said that the what is the graph the algorithm we use for the Department of Treasury, but I would like to know that, what kind of graph algorithm we use for maybe another project. So even though he said that, okay, I cannot find any graph algorithm for the Department of Treasury, but you will use this kind of algorithm from this project or that project, even though, they give you some, additional information. That's the other thing is these are first we get the loading the graph, we get our blob storage, getting all the different kind of the documents. If they are not a PDF, we convert them to PDF, create them to the small pieces, split them to 5 pages. After that one, we just connect to our Memgraph, and also we're creating a different, the constraint, and we split them to the child and the node person, the create first documents. According to this documents, we create the parents. Under this parents, we create the child. And then, we just go to the NER using the OpenAI to creating the embedding, sorry about it. And now we put to, what is that one too? Creating all the child's embeddings. And then we load them directly inside to our graph, with each of them has their embeddings, and then using the documents, extracting all the NERs, using this NER to finding all the different the documents, how many the NERs they have it, clean them, count them, how many times is mentioned about in this documents, because some of them is just showing up to the different numbers, and we don't want all the NERs. For example, there is some common name of the NE, because it's finding everything. We don't want all the NERs in our graph, creating the hallucination. We create our list of the NERs, and now what is their similar, because when we ask the question, for example, if somebody is mentioning about the United States Department of Agriculture, we would like to go to here. Or if they said USDA on the question, we would like to go there, making them just one model for the getting all the results. At the end, we load everything with their the NER count. What this is for example, the one NER, for example, ED, but it should be Department of Education in our graph NER. So documents NER is different than the graph NER. And then we load everything at the end, as you can see there, creating the NER nodes, and then with their finding all the parents, we mentioned about it, and also putting our age with the weight, how we can use our filtration in here, it show up to here.
Okay. Do you want to show some of the DeepSeek stuff?
The DeepSeek one. Sorry about it. So the DeepSeek, there is a 2 different one that we used. We use the DeepSeek same as the OpenAI, 3 different locations. The first one, give me 1 second. Yeah, here we are. We're using the first, creating the generate our answer. The other one is the using the model. For example, this one is with the OpenAI, the text embedding. The other one is because, as you know, that the DeepSeek R1 is so big, so we just use the the quantized version of that one. Using the Olama one software, using the DeepSeek model. This is for the generation of the result. The other one is creating the embedding using the DeepSeek model. So the same child text, but 2 different embedding. One from to the OpenAI, the other is coming from to the DeepSeek. And then when we ask the question for the generation result, also we use because we're using the DeepSeek, the embedding, we're also using the generation with the DeepSeek, the model.
Do you have any examples of the reasoning?
Oh, for the document?
Yeah, for the DeepSeek, yeah.
To be honest with you, I need to. Sorry about it. This is the general, when we use the OpenAI version, we have the general question on the different use cases, the general question about any documents, we can also play with the temperature. We are also preparing some case studies, project plan, and also proposal. And these are our parameters. For example, we would like to get the 100 the child documents after the vector search, but we would like to use the top 25 from the re-ranking. These are just the parameters. We can play with them. In the DeepSeek version, we have the another one right now. Just the reloading the documents and using a different DeepSeek models to to ask a question, and also we can use just a standard llama or the Pi4, the Microsoft Pi4 model.
Okay. Will it be too slow to do an example, or?
Do you want me to do
yeah,
something
sure.
like this?
Okay.
For example, if I put our employee, this is only a 70 documents. Is just creating everything on the backend.
Maybe until we wait that to load, can you tell us, like, did you notice any differences between using DeepSeek and OpenAI model? Like, what are your thoughts on that?
Also, the DeepSeek, because of reasoning model, it's also giving us the think section, how it's finding the result. Other than the standard decoder LLMs, they directly they give the this is the answer. So you trust the LLM nowadays. The people trust for the LLM any Gen AI is 75 to 80%, even though the OpenAI. But the DeepSeek, because of reasoning, giving you okay, I found that using this one, and that one, I get that result. You can also check how the model is finding the result. So if you see when you read this one, I would say, for example, from here, when I ask the question, it will, it's using the DeepSeek 14B. These are 14 building parameters, but it's a, the for quantization. And then, 1 second, it's, running right now. It will, saying that, yeah, it's generating right now. It's giving me the, oh, come on. I don't know, you cannot still see it.
Right? It'll come. So, yeah, there we go.
Okay. So yeah, I put the question is a little bit different than the standard question, but this thinking section, it will give us the the information about okay, he said that first of all I remembered the getting this one, looking for the what they are, and then it's trying the finding a different the section or the different the child is mentioned about it. As you can see, the first context, second one, third one, this is the best part for the any reasoning model. It cannot be only a DeepSeek, it can be also the OpenAI O1 or O3 right now. I think O3 is also running right now. So give you the how is finding the results. And then if you are not, convinced with, this thinking section, the reasoning section, you can, change your question or, getting the better answer.
Do you want to show the other interface, the Angular one? It's a bit faster.
Oh, the Angular.
Yeah, is it up? And
yeah, it's
okay.
Until that, we have one question. So just a sec, let me put that up. So do you plan to provide an example design perhaps in GitHub to act as a starting point? Like, if not, maybe like, can someone reach out to you, or like, what's the way of kind of you helping them out or whatever?
Yeah, I mean, you can definitely reach out to us. Yeah, the code is proprietary, so we're not putting it on GitHub. But to get it started, it really doesn't take a lot. I mean, you can see it really exists only in a few notebooks. So we can definitely help you out. A lot of it is kind of all that getting the data, together. A lot of it just, bread and butter like data processing, and then there are the three components, right? The data processing, the algorithm to retrieve the documents, and then the prompt engineering. So, if you kind of get those three right, then that's kind of the basic structure of any RAG application.
Yeah, I sent in the chat your website so everyone knows where you're at.
So we have, we use different language models, here at FI Consulting, depending on, a lot of it depends on like data privacy and, how private the data is. Some people don't feel comfortable, with OpenAI, and they want an on-prem language model. There are agencies out there that aren't really comfortable with DeepSeek, at the moment. So, as Sinan showed you, we had different ways to toggle the language model depending on what kind of level of security is the client is most comfortable with. And right now, we're going to show you an Angular interface, right?
Actually, yeah, that's like down at the moment.
Oh, it's down. Oh, okay. I'll forget it then.
It's really not too much different from the.
Okay.
I mean, one live demo, so asking for another one.
I know, right? Yeah.
Yeah.
Okay. Yeah.
Okay. Hi, everybody. I'm James. As you saw the demonstration, you might be asking yourself how all this was basically set up. What is the infrastructure behind it? So we host a lot of our applications using Azure. So we use an Azure virtual machine under the hood here. Also, in order to create Memgraph, what we did was we created a Docker container. So we used the documentation that Memgraph provided, which was, I would say, was excellent. I found it a lot easier to use than other graph vendors. And so basically, we spun up a Docker container. We used the Memgraph console, created a username and a password. We ensured a persistent volume. And then after that, we were basically very easily able to interact with the Memgraph web UI, just to basically see the graphs being persisted. And just this whole process felt very seamless to set up. We've tried multiple graph vendors before this, and it was a lot of overhead. As Sinan had mentioned before, basically the LLM that we're using, at least for this model, is a DeepSeek, and it's the quantized version. The infrastructure you would probably need to use, like the 671B parameter version, would be thousands of dollars worth of infrastructure. So we have a very small LLM that we're using here. And this is hosted using the Ollama platform, which you can use freely just to host different LLMs and then run that against whatever you're looking at, in this case, a graph. And so initially, we had kind of experimented with a couple of different GPUs because, of course, like as a lot of you probably understand, in order to kind of carry out these operations, you need a lot of kind of processing power with GPUs. So we experimented with a couple of different GPUs. Initially, we kind of went with like the greatest possible one we could find, which was the A100. Now that was great. That was very quick. I think it took us about 5 seconds to just kind of get a quick query back and forth like you saw before. However, to kind of run this 24/7 probably would have cost like $3,000 a month. So we experimented with a couple of different GPUs, and eventually we found like the NVIDIA T4 was a good balance between performance and cost optimization there. So we were able to really drop our costs down. I think it came to about $500 a month. So that's basically $30,000 worth of savings there. So just kind of like a lesson learned. You don't necessarily need like this powerful GPU or infrastructure to run an operation like this. You can keep it very simple and small in terms of your infrastructure costs. So if anybody's looking to build something like this, just understand that the GPU and the infrastructure is actually quite simple, especially with everything Memgraph has set up for us. It's very easy to get up and running with this. So yeah, Memgraph played a very instrumental role in this whole arrangement. We were able to basically quickly create persistence with our volumes, create backups, copy and paste different Memgraph databases between different servers. It was like seamless. So I think that was like a really good basically advantage between other vendors, is just its ability to kind of alternate between different servers and kind of pass data back and forth. So it was just a lot less overhead there and complications and also costs associated with this whole operation. Also, we noticed, me and Sinan were talking about this, we noticed there was a lot less latency and also like higher throughput here, just with the different graph traversals. And I think this might have come down to how Memgraph structures their architecture. I understand it's like an in-memory architecture, so I think this kind of helped with like faster real-time graph analytics and processing with these complex graph operations. So yeah, overall, the whole process of setting this whole up, the infrastructure up, was very painless. The database amazingly scaled like very well given the input you were giving it. We had like hundreds of thousands of different nodes and various nodes and edges, and we didn't really see very much of difference between these other graph operations. So basically using Memgraph along with the DeepSeek model for this RAG operation was it was very minimal overhead and seamless. So
yeah. I would add too that it's you can improve speed algorithmically. Yep. Anyone can just kind of crank up the computing power, but we find that our fastest improvements, right, are just by making sure we have the right graph traversal, making sure that we're filtering sections of the graph so we don't have to do a comprehensive vector search throughout the entire database, and those techniques, it's free, right? So you can actually make your application run a lot faster by just making sure that all your algorithms are run correctly. And then you can always crank up the compute power if that doesn't work, right? So, all right. Is that it for us? And just kind of, any questions? And
Amazing. Yeah. Thank you so much for the presentation. It was really nice. I don't see any question now, but yeah, I would say from my side, I think that James now answered a lot of questions that I had in mind. But thank you, James, for the nice words, especially in terms of experience, because I'm from the developer experience team, so it really means a lot. And yeah, I think you kind of pinpointed all of the important things when building a RAG system with Memgraph, like what are the important things you need to look for in the graph database. We have one question, and I think then we can wrap up. As the question is, do you have any data for private cloud deployments for people that have private data?
Sorry, what the question? Oh, data for private
let me
cloud.
bring it here. Yeah. So do you have any data for private cloud deployments?
Right. Well, if I'm understanding the question, definitely this can be under a private cloud. I think we showed that, and again, like we deal with like government agencies and things like that, and they really are very protective about data leakage and things like that. So the DeepSeek example is actually entirely taking place, in the private cloud. No information is going outside your cloud environment, and that's very important again for the data security aspect. Obviously Memgraph can be installed in your private cloud as well. So right, and then if you're asking for sizing, that's kind of a infrastructure question. It really depends on your environment, how much compute power you have in your private cloud. Obviously, the advantage of going out to AWS or Azure is that you can take advantage of a lot more computing power. However, I think we have demonstrated that we can actually run good applications on a very small GPU. So I would say that you'll be able to come up with something pretty powerful and pretty responsive within your private cloud.
I would just add that if you're going to do this, obviously go with NVIDIA because it has like this CUDA interaction. It's kind of like a meme at this point, but trying to set up like drivers for these other tools for AMD, it was a real pain for us, a real pain point. So if you do this, just make sure you go with NVIDIA. The driver setup is a lot simpler.
Yeah, thank you. And I send them more information just regarding Memgraph, although all of this has a lot of different puzzle pieces. But yeah. Okay. Okay, the recording will be available. I see that's the most common question. I guess a lot of people are interested whether they'll be able to see this again. Some of them couldn't join at the beginning. Thank you all for participating. Thank you, Robert, James, and Sinan for doing this, for joining Memgraph community call and sharing your knowledge. I think it was great, especially like you had also a presentation and you shown us the notebook and then the live demo. So as said, another one would be like crazy. So kudos on that. And thank you for sharing your knowledge. I mean, it means a lot. I see that you have a lot of experience, and our users love to hear that from people such as yourselves who have that experience. So yeah, I hope you enjoyed as well. And I guess that's it. Thank you for joining, and everyone else, see you at the next Memgraph community call.
Thank you.
Great.
Bye.
Thanks, guys.
Thank you. Bye.